So today we're going to talk about how water is stored underground. We talked a little bit before about caves and the karst, so this kind of brings it together and understanding how it's a useful thing for us. So first off, how does water get there? Well, the surface water that is either from rainwater or snowmelt will trickle down between the soil and the sand grains and cracks in the rocks and kind of just percolate down. It will be pulled down by gravity. Of course, it depends on the type of rocks in the ground. Not all rocks will allow for that filtering to happen. So let's talk about this, the type of rocks. So one type of ground that we're going to talk about is a permeable ground. If it is permeable, that means that the substance of the rocks, the grains, are large materials, larger, like sand or gravel, where there will be spaces in between those grains or those smaller pebbles for water to get through. So water can pass through it. So, like sand, gravel, um, it's not, it doesn't have to be like a fast filtering through, but as long as it can get through. The opposite of permeable ground is impermeable, which means that those particles are so tiny and small that there's no spaces in between. So this would be like mud or like silt and clay particles that would not allow for water to pass through it. So it's more of a barrier. So that's the two types of rocks and ground that is important to know about for this topic. Permeable ground, it's large enough, it can pass through it. Impermeable, they're smaller size grains, so they're so tightly packed together that it acts as a barrier and water can't travel through it. Okay, so where water ends up, there are some different zones to know. Water will trickle down through an impermeable rock, right? So if there's sand or gravel, it will go right on through. That's the permeable rock. The first layer that it passes through is called the unsaturated zone. So there's still at the end after the water has settled, there's still gaps of air in it because water hasn't settled in it. It's just passing through. So it's unsaturated. And the saturated zone is where it ends up. That's the layer that the water settles in and is stored in. So there's no gaps of air. It's all completely water. So again, water trickles through permeable rock, going through the unsaturated zone, ends up in the saturated zone, and then the unsaturated zone stays not necessarily dry, but there's more gaps of air in it than not. Also, it's important to note at the very top of the saturated zone marks the water table, which is the boundary line of where there is water versus no water. So in the underground, if you, and we'll talk about this in a second, if you were searching for water like through a well, you would need to get down to the water table because if your well is only in the unsaturated zone, it will be dry. So the water table, and that will change all the time based on how much rain we get, snow we get, stuff like that. That water table will rise and lower depending on where that saturated zone is marked at. So the unsaturated zone and the saturated zone are not set at a certain distance or depth. It changes. So here's just another picture showing you what I just talked about. So again, On the surface, directly underneath it, that's the unsaturated zone. That's the water trickling through it. It will eventually rest on top of a impermeable ground. So that's the barrier. That's what's stopping the water from trickling further down. So that's the resting spot, and then the water will fall into that saturated zone, and then it is marked by that water table. Okay, so using groundwater. This is where it's useful for us. Aquifers. This is any underground layer of permeable rock that will hold water and allow it to flow, which is going to happen because this is it is a permeable ground, so the water has the ability to flow through it. It may not be like a bathtub down there as it's going fast, but if, for example, one farmer takes water out over here from a well, it will even out the aquifer, and the water that's in there will balance out, so it has the ability to move. It ranges in size. Aquifers do, and there are many, many, many different kinds of aquifers around our country. It's not just one big one. But the largest one is actually under the Midwest, and it's called the Ogallala Aquifer. It's a fun name. Very, very critical to farming in Kansas. You'll learn more about that after this video. And it's really important to know aquifers are not an unlimited source of water. If we take out more than what's replenished, it will go dry, just like a normal well does. And since the aquifers are so critical to our agriculture, we need to keep our eye on that. And obviously, over the last decades, western Kansas is getting much, much, much less rainfall. It's going through droughts, which is where like wildfires happening in Colorado. So there is less rainfall to replenish what we are taking out. So that's a crisis that we're going through, for sure. Just another picture, just to make sure you understand the process. Again, you have your barrier where the water is being kept at, and it's stored underground. Okay, the water table. Water table, like I said before, is constantly moving as the water flows underneath it. So if we start to take out way more and it evens out, that water table will lower. But after a large rainfall or a really high snowy season in the winter, in the springtime, that water table will rise up. And it will typically follow the shape of the land. So if there's mountains or something like that, it will kind of curve along the feature of the land. And like I said, it changes with the seasons. It'll be usually highest in the springtime and lowest in usually like late summer. And if you were to drill a well, you want to make sure that you put it well into past the water table so that it is fully in the saturated zone, which is the aquifer. If you're getting drinking water, you're probably getting it from an aquifer. You want to make sure that it is well beneath the water table, especially going through times of droughts. I'm sure there's plenty of wells in the country that are completely dry right now. And that's it. That's all you need to know about underground water.